Hello class, I want to talk to you about the periodic table. The periodic table was developed and organized and originally put together by Dmitry Mendeleev, a Russian chemist. And he did this back in the 1800s, back in the late 1860s. And so he didn't have all the information about the elements whenever he tried to put together his periodic table. And so he did a pretty good job. He didn't have all the elements yet. Not all the elements were discovered. They didn't really know about protons yet, and so he couldn't use the information that we know about protons now, numbers of protons, and put it together. But when he took a look at the periodic table, he organized it by chemical reactivity. And so remember, chemical reactivity talks about, well, how easily does a element combine with something else, or how easily does it, react with something else to form a new substance. So that's one way you organized it. A second way you organized it is by taking a look at, well, when something does react with a substance like oxygen, what is the formula that it forms? And then finally, a third way that he organized it was increasing atomic weight. Alright, so reactivity, like I said, is how reactive a substance is. And you notice everything here in group 1 is very, very reactive. So everything in this first group, these are the alkali metals. I know we haven't learned the names yet, but the alkali metals are very, very reactive. Hydrogen's thrown into that group even though it's not a metal because it's also very reactive. And so all these elements in this group are very reactive, and that's why they're put together. Over here in group 18 on the far right, we have some gases, and this family is called the noble gases, and these things are very, very unreactive. They're so unreactive, inert, that they do not react with anything. So they're always found by themselves. And so you can see this is how reactivity can be used to put elements into the same family. Now formulas, some things are reactive here in group 2 as well, and so you had to sort of differentiate, well, what goes in group 1, what goes in group 2, and so we take a look. Whenever sodium reacts with oxygen, it always forms a compound, 2 sodiums, 1 oxygen. Whenever potassium forms a compound with oxygen and reacts with oxygen, 2 potassiums react with 1 oxygen. Whenever lithium reacts with oxygen, it makes Li2O. And so you see in group 1, anytime it reacts with oxygen, there's always going to be 2 of the metal and 1 of the non-metal. And so that's what's meant by formulas. So everything in the same family will react with similar things like oxygen in the same way in the same ratio. Whereas if we look at the second group, they react slightly different. In the second group, let me get this out of the way here, beryllium, when it reacts with oxygen, will be BeO. 1 beryllium, 1 oxygen. Magnesium will be MgO. 1 magnesium, 1 oxygen. And calcium will be CaO. And so all these things in this family, in this group, react in a 1-to-1 ratio. So Mendeleev used that information to put things into families too. Atomic weight, remember, we didn't know anything about the atomic number yet. We didn't know about the number of protons. And so by atomic weight, Mendeleev looked at the mass, the atomic weight, and said, all right, as I go left to right, the atoms, the elements will get heavier and heavier. And so this was a pretty good foundation, pretty good organizational system, but there were some kinks, some flaws in this system. And so if you look at cobalt and you look at nickel, cobalt's actually heavier than nickel. And so now we know the modern day system, we don't use atomic weights, but we use atomic numbers, which is the number of protons. So we go 25 protons, 26 protons, 27 protons, 28 protons, 29. And so now we have this nice, neat periodic table, which we'll become very, very good at using and can pull a lot of information once we learn more about it. So hopefully this helped you with the creation and the history of the periodic table and how it came to be.